Now let's count in thousandths. So first we have 0.623, so that's 6/10ths, 200ths and 3,000ths. If we count in thousandths, we then have 0.624, then 0.625. What are the next 7 numbers in this sequence? Well, if we show them, you can see that counting in thousandths is similar to counting in ones. The only thing we need to change is 0.630. That's usually just written as 0.63 because we don't need zeros on the end of decimals. And to see why not, let's count using the place value counters. So we can keep on counting in thousandths until we have 10,000ths. But when we get 10,000ths, we can exchange those for 100th because 100th is the same size as 10,000ths. But now you can see that we have 6/10ths, 300ths and no thousandths. So rather than writing 0.630, we don't need to write the 0 in our thousandths because 0.63 also tells us that we only have 6/10ths and 300ths with no extra thousandths. Then we kept on counting in thousandths until we got to 0.632, so 6/10ths, 300ths and 2,000ths. Now we start with 0.795, so 7/10ths, 900ths and 5,000ths. Next, we'll count 0.796, 0.797, and what are the next 7 numbers in this sequence? Well, we're counting in thousandths, and that's similar to counting in ones, except that when we get zeros on the end of decimals, we don't need to write them. 0.8 is the same as 0.800. And to see why, let's again count using the place value counters. So we started with 0.795, which we can see here. If we keep on adding thousandths counters until we get to 10,000ths, we can then exchange those 10,000ths counters for 100th counter. So that means we have 7/10ths and 10/100ths. But remember, if we've got 10/100ths counters, we can exchange those for 1/10th counter, because 1/10th is the same size as 10/100ths. So then we just have 8/10ths counters, so that's why we can just write 0.8. Then we can keep on counting in thousandths, but we need to make sure that we write 0.801, because remember, we're counting in thousandths, not in hundredths. We keep on counting until we get to 0.804, so that's 8/10ths, no hundredths and 4,000ths. Now we start with 2.593. So that's 2 wholes, 5/10ths, 900ths and 3,000ths. What will the next numbers in this sequence be? Well, we can show them, and again there's one value that we need to change, because we don't need to write zeros on the end of decimals. So if we're counting in thousandths, we go from 2.599 to 2.6, then to 2.601. And again, we can use place value counters to explain that. If we keep on counting in thousandths until we get 10,000ths, we can exchange those 10,000ths for 100th. But now, doing that means that we have 10/100ths counters, and 10/100ths is the same as 1/10th. So now we have 2 wholes and 6/10ths, or 2.6. Then we keep on counting in thousandths, so we need to make sure that we have this 0 in our hundredths, and in the end we got to 2.602, so 2 wholes, 6/10ths, no hundredths and 2,000ths. Finally, we have 1.995, so 1 whole, 9/10ths, 900ths and 5,000ths. if we complete the sequence, you can see that we get 2.000. But if you have a decimal point and then zeros on the end of a number, you have a whole number. So 2.000 is just the number 2. And we can see that again if we count using the place value counters. We started with 1 whole, 9 tenths, 9 hundredths and 5 thousandths. We kept on adding thousandths, but then when we got to 10 thousandths, we had something that's the same as 2 wholes. To see that, spot that if we have 10 thousandths, we can exchange those 10 counters for 1 hundredth counter. But now we have 10 hundredths counters, and we can exchange those for 1 tenth, because 1 tenth is the same as 10 hundredths. But now we have 10 tenth counters, and 10 tenths is the same as 1 whole. So that's why we have 2 wholes altogether now. Notice we were just exchanging here. We were just exchanging 10 of one place value for 1 of the place value to the left, and we did that 3 times. So that's why after 1.999, when we added just 1 more thousandth counter, we got 2 wholes. Then we can keep on counting in thousandths until we get to 2.004. So that's 2 wholes and 4 thousandths. And it's important that we remember to write zeros in our tenths and hundredths because we're counting in thousandths, and the thousandths digit always has to be the 3rd digit after the decimal point.